starters, if I have a positive velocity, what's that telling me? I'm moving forward. Okay. Doesn't mean you're accelerating.
Oh wait, yeah.
No, okay. If I have a negative velocity, it means I'm moving backwards. So just look at this graph for a second. See how velocity is positive here, above the x-axis? So until I get here, I'm moving forward. Till I get here, I'm moving backwards. And then what am I doing?
You stopped.
I'm stopped for a few seconds, right?
Yeah.
It's like a second, I pause. Then I'm moving forward. Okay. Now, here's the idea. A lot of people get thrown by this whole thing. Okay. This does not mean I'm stopped. It means I'm moving at a constant velocity. It's pretty hard to do when you try it. Okay. It's pretty hard to move the exact same speed for a while. Okay. But anyway, it means here I'm actually moving quicker, right? My velocity is getting faster. Then it's kind of leveling out, and then I'm getting slower, which makes sense if I'm going to change direction. You've got to stop it momentarily, right? To switch direction. And then I'm getting faster. Even though this is going down, because think about it. The further I am from that x-axis, the quicker I'm moving. Because the fact that I'm negative is just telling me what direction I'm going, correct? But I'm moving pretty quickly here. Then I'm slowing down, slowing down, slowing down, slowing down. Stop for a moment. And then I'm moving faster the other way. So the steeper it is, the faster I'm moving. But it has nothing to do with positive or negative. That just tells me which way I'm moving. Okay? So we're going to write this up. Let's look at my scale. How much is each tick mark based on my scale? That's your y. Look at the x. Four. Right? Each one is 4?
Yeah.
Because 9 tick marks, and the whole distance is 36 right there. 36 divided by 9. Okay, so each one is 4. So 4, 8, 12. So that's probably what, 14? Yeah? Roughly in between? Okay, so we start off moving forward quickly. We start slowing down. And change directions when t about 14 seconds. No, not 14, 14. Does everyone agree with that statement so far? I've just described this first chunk. Okay. Then we move quickly backwards. And start slowing down when? Can you tell me when we start slowing down?
About 20 seconds.
About 20 seconds, right about here, right? It's about 20. Does everyone agree with that? Because I start going towards the x-axis. So I started slowing down when t is about 20 seconds. At about here, so let's see, that's 20, 24, so we say that's what, 26? 26, so from 26 to, looks to be about 32. Okay. From t equals 26 to t equals 32 seconds, we're stopped. Then what do I do? Then I move forward quickly. So think about it. I'm giving you the velocity function. You're describing my movement. So you're describing my position function, correct? how I'm moving. But the key thing is, in order to describe movement, you need to look at the velocity graph. Yeah? It's a good question. There's paragraph kind of descriptions. Now, if you have some in homework like this, the book may give a more elaborate description, but it's just describing what you're walking. And as tomorrow we're going to do is you're going to have a graph like this. You're going to try to make the graph with your movement. Okay? So tomorrow I'm going to give you, on your calculator, we'll show up a graph like this. You're going to have to try to match this by walking. It's harder than it sounds. Okay? Because your speed has to be just right, or else like you're going to be slow. If you go in the wrong direction, it's going to be down here, that kind of thing. So, yeah. It's going to be interesting. It's fun, though.